Hello, everyone. Thank you for joining us today for the AIAA Scientist Speaker section hybrid meeting. Today, a very exciting program. I will explain a little bit more, but because our section chair, Dr. Michelle, is actually here. So, Jeff, do you want to say a few words?
No, not really. Just good afternoon, everyone. It's great to be here having in-person events again, and I look forward to hearing the presentation. Excellent.
Okay. Actually, because today's event is also part of Young Professional Networking, so we have currently our YP chair say a few words and about her vision.
Hello. Hey, I'm Courtney. I'm the Young Professional Chair here at AIAA Los Angeles, Las Vegas. Just want to say thanks to people who came. This is kind of one of our early events now that we're doing events back in person, but we are definitely, oh, he's moving it towards me. Here we go. Hi. We are definitely planning some upcoming events now as things are starting to get back in person, as we're able to do some more things like this. Definitely going to have some things coming down the road, trying to start getting some more engagement from young professional people in the area and anyone who's an AIAA member around here. So thanks for tuning in.
Oh, hi. So I'm Dan. Hello, I'm Dan. I'm our our workforce development chair. And welcome.
Daniel is our career workforce development chair. Okay, so today's program, first our main speaker is Dennis, Mr. Leung. There might be a second speaker, Alan Chen, but he may or may not be showing up. Otherwise, we'll set up the Mars driving software for demo after the presentation. And there's a gentleman is only online, Manny, Mr. Pimenta, for virtual moon. Okay, so I first met Dennis a few years ago. He has a beautiful demo for Northrop Grumman. Now he has his own consulting. So let's welcome Dennis for the presentation.
Thank you very much. For those who probably tuned in the last meeting that we had, some of this information will be kind of the same. Some of it will be new as well. I will also be showing a couple of videos here. I no longer have access to the demos that I developed at Northrop Grumman. But the videos itself will show in pretty good detail what exactly we did and the reason why we did it. So before we do that, let me
It's still the first page.
yeah, it's not.
Maybe restart. Okay. Oh, okay.
No,
We use
this-
the new cable.
Yeah, we're using the new cable.
I'm using this small. Maybe disable the preview.
There we go. All right. All right. So let me go through a little bit about who I am, what I've done over my 20 some odd years career in the aerospace and defense industry. When I got out of USC, I started off working with the US Navy as a civilian contractor under their Trident II ballistic missile program. So spent a little bit of time there, moved on to NASA up at Dryden Flight Research Center, doing their X-43A hypersonic vehicle. spent a little time there, and then I spent the bulk of my career with Northrop Grumman building satellites. My main expertise in that was integration, test, and launch. So pretty much everything from design, production, testing, logistics, getting it out to the launch site, and launching it, everything in between was my expertise there. So I spent a good 20 years there doing that. My last couple of years at Northrop Grumman, I was tasked with building a brand new smart factory to increase our production capacity for building space products. So that included redesigning a brand new facility, adding in all the stuff that was not put in during the 80s. In addition to that, we also put in a lot of new technologies. Technologies such as digitization of information, augmented virtual realities, a lot of robotics, things that kind of helped us along that we have to keep up with, that a lot of other industries have currently been using that we have not in the aerospace world. So once I was finished with that, I retired from Northrop Grumman 2 years ago, and now I have my own consulting company, and I do a lot of outreach with educational institutions and so on and so forth, and doing guest lecturing as well. So why do we want augmented and virtual reality systems? If you've paid attention to what these systems are and where they're currently being utilized, you can see that we're moving further and further away from hands-on to hands-free. Just about everything now is moving towards hand-free. You can see all these new companies coming out, Neuralink, all these things where you can use your eyes, your thoughts, your just everything without having to use your hands. We're so used to computers and stuff right now that the next evolution is hands-free. And you can see that here, right? From paper to computers, now to headsets. How you use that information and what is available out there depends on the type of equipment that's available to you. And you can see that here. Before, paper, fantastic. Laptops, awesome, right? iPhones, even better. Now, glasses, I don't even need my hands. Voice activation, that's the next generation, right? A picture is worth 1,000 words. That's exactly what augmented virtual reality is. And you can look at some of those numbers right there. Visual information, 65% retention rate compared to anything else, right? Just look at those numbers and it tells you right there that this is really what's going to help, whether or not you're in the aerospace industry, education, medical, so on and so forth. This is one of those next generation revolutionary types of systems that's really going to push our industry into the next level. As you can see here, visual information processed 60,000 times faster than reading. We are hardwired for visual information. You'll see in some of my presentations a little bit further down too as well, trying to write or describe something in words is going to take you much longer, either in paper and words, than if you just showed a picture. That's exactly what this is. Right? And I'll tell you why that's important in our industry as well as we kind of go down. But just look at that. Remember, most of everything that comes in our view is visual, and we process it way faster than we think. So when we get into AR and VR, a lot of people right now who don't really understand it, they look at, wow, this is a fantastic thing to do. It's a fantastic thing to do, great. But they think of it as a one-off. And this is where we have that opportunity to show them this is not a one-off kind of entertainment system where it's only for gaming or it's only for this specific product usage. And how do we do that? We need to have a strategy. Corporations, educational institute, any kind of organization or even the government that wants to utilize the system must have some sort of AR/VR strategy. That includes infrastructure, How do you plan to utilize it? What's the maintenance look like? And so on and so forth. When you have all of those lined up, then it becomes more and easily understood and adoptable by that organization. If you come in and say, hey, I just want to use this, great, who's going to maintain it, right? Does our Wi-Fi system even able to handle that kind of bandwidth of the data that's being transferred through? So these are the kind of questions that we have to answer if you want mass adoption of this kind of technology. With most of us being engineers, and this is what I've seen time and time again, is that we love to re-engineer everything, right? When you're an engineering company, I want augmented virtual reality, and I've seen this in a lot of trade shows where they develop their own. They make their own hardware, they make their own software, even though that's not their forte. But if you go out and you look at these other companies, they've already done it. They've made their hardware sometimes agnostic to their software, so you can switch between the two. So instead of spending your time, which is not your forte, in building these AR, VR devices, work with these other companies where they've poured so much money into it. For example, everybody remembers Google Glass, 10, 15 years ago, and then it went away. It didn't go away. What they did is they realized it wasn't ready for mass adoption in the regular consumer world. They took it back and made it an enterprise solution. So they were working to make sure that companies would use it because they're more willing to use it because it doesn't have to look cool, right? And they realize that it's going to be a bigger impact from an enterprise perspective before it would be from a consumer. So that's what they've done. So the last decade, they've pulled it back. I've talked to their Google Labs before, and all their new glasses has come out. It's very, very powerful. So what I'm wearing right now, it's no bigger than this, right? In their new hardware systems. So just want people to realize there's so many companies out there that's already doing it. We don't need to reinvent the wheel, right? Unless it's a specific case, and specific cases meaning, for example, like in the military, their F-35 fighter jets, for those who are familiar, the new helmets that the pilots wear are essentially an augmented reality system where they're able to see through the plane with cameras everywhere, right? So they had to develop that because that is very specific. But for things that we need to use it for in a production environment, educational, training perspective, the hardware that's currently out there right now more than meets our needs. So there really isn't a need to really reinvent the hardware on that. Now, what are some of the use cases in aerospace? This is just a really generic life cycle of what we do. First you have evaluations, proposals, design, product integration, launch, and sustainment. And the next couple of slides, you'll see that there's applications in each one of them. And everything that you see here in my presentation is really just kind of scratching the surface of what we can actually use this for. There's so many different applications for this that it needs to be explained to people on how it can help them from a financial return perspective to an efficiency perspective to maybe some of more of the softer areas such as customer confidence perspective and so on and so forth. So what do we usually do in a traditional engineering sense, right? Let's just take proposals, for example. Customer comes in, hey, I want you guys to build this satellite. Give me a proposal. I've worked on enough proposals where they sit here and goes, each section, 7 pages, 5,000 words, that's it. You go over it, I toss your proposal. So, okay. So now, which some companies have done this, where they submit a VR headset with their proposal in it, you get around that. There's no word limit, there's no paper limit, okay? They haven't caught up quite yet, but this is one of those ways that you get around it, right? But this goes back to a picture is worth 1,000 words, right? Design reviews, and I have a video on showing this as well too. There's been so many design reviews, I'm sure those who have been engineering or even not in engineering, where somebody's trying to explain their concept to you on 40 to 50 page slides. And I'll give you an example. During my time on JWST, I was in one of their reviews, and in one section, they were explaining a specific part of hardware, and they went through 56 slides. I knew exactly what they were doing and what they were talking about. I was lost. Okay, so I can't even imagine what our customers were feeling at that point in time. And in the video that I'm going to show a little bit later, you'll see the difference between PowerPoint slides and actually being immersive in that environment. One of the other bigger ones is logistics. We do what we call Trailblazer Activities. Some of you are familiar with that. We spend a lot of money to check, double check, triple check, quadruple check to make sure everything's okay. So what do? We bring the hardware down. For example, if it flies, we fly a C5, transport military plane down to LAX, $500,000 per direction, so $1 million round trip flight, just to check that empty container fits inside. So we spend $1 million just to check that it fits inside. And let me tell you, we don't bat an eye at it. Want to do it? Sure. It's a great risk reduction. Go ahead, here's $1 million. Now, imagine if you had a complete model of the airplane, which you do. You have a complete model of the shipping container, again, which you do. A lot of these systems now have physics engines in there where you can add gravity and so on and so forth, so you can understand how things work. And then you can run scenarios. You can run hundreds of scenarios through there. And if you're still not sure, then you can go ahead and put the money down to bring that plane down. Or maybe you don't have to build a life-size mock-up. We've built life-size mock-ups. We spent millions of dollars, hundreds of hours to build a mock-up that we use for a couple of hours and then it gets mothballed. Just because we want to train, we want to trial it, we want to see what it looks like. And again, this is all stuff that can be done in a virtual environment, but we just don't quite do it. One of my examples that I've always used here was, would you want to get on a plane with a pilot that's never been on a simulator? So the other question being is, why would you let these technicians do a critical operation on billion-dollar hardware that took 10 years to put together, be the first time to try it out, except looking at it on paper? There's no reason, right? We can certainly make simulations for them. We just don't. And why don't we, when Walmart is doing it? Walmart has bought hundreds of headsets, VR headsets, to train their cashiers on how to do customer service. Walmart's doing it. We don't, not in aerospace, because we know better, right? So that's just one of those things that we have to kind of change our cultural aspect of this technology and how we apply it to all of these kind of different aspects of our world here. And I know I'm concentrating a lot on the engineering side, but you can see the applications from a medical perspective. I'll talk a little bit about that right now. Medical perspective, operations. A lot of my family members are doctors and surgeons. And so I talk with them and I listen to what some of their issues are. And when I kind of point them in the direction of some of these companies that are doing these simulations of using CAT scan or CT scan data of a person's body and rendering in a 3D environment, now they can put on the headset and they can see everything in a 3D environment. They can see blood vessels, they can see bones, they can see muscle, they can see everything in a 3D environment, and they can manipulate it, right? Now that changes their perspective of what exactly it is versus, again, looking at a 2D piece of paper, right? Or a drawing of someone. So now with them, they understand that they have that depth of perception that they don't have to imagine, it's there. So now it's more ingrained on them. So when I sent them to those websites of these companies doing it, you can see their jaw drop. Wow, that would be absolutely fantastic for us. There's this one company also that's using a HoloLens. And for orthopedic surgeons, what they're doing is they're projecting, overlaying information right on top of the body, the human body. And it's telling you at what degree the drill has to be so that the doctor does not have to guess, right? It's showing him exactly where and whether or not you're off. So this is the kind of information that's available to him without having to go back and forth to a laptop or something else, or just straight from his memory. Now the information is there. Another one of the industries that's using it, defense is using it. They partner now with Microsoft with their HoloLens to help battlefield medics, where they're only trained in a certain amount of procedures. Now with the HoloLens can analyze what the injury is and provide information and to help, right? So now that helps both the medic and the injured person in terms of saving their life. So there's a lot of different kind of aspects of how we use this augmented virtual reality systems. Let me go to some of the videos here. So this one we didn't spend too much time on. This is more of a proposal, kind of showing people what exactly this program is. So I had our interns develop this one, but you can see here how much more information you have about this one particular program and vehicle versus reading it on a black and white sheet of paper, maybe something, right? You've got motion, you've got sound, you've got music, and you can influence your customer into saying you are the right person to do this, right? Those are really the soft parts where it helps you win or lose a proposal. So some of the things we've got here is we've made a scale model of the vehicle itself. You can toss it, it comes back, you can explode it out, and all the pieces open up. You can put as much information as you want on there, right? This is just what my interns came up with for countdown for travel. So now I don't have to describe what L-Cross does. You can see it by itself. You know what it does. Crashes in the moon to the polar. Gives you some information on the launch vehicle itself. You can display it any which way you like. Now this is in a virtual reality system. We use the HTC Vive for this. The HTC Vive was one of the systems we used because it was the most powerful at the time. It was the best one to use. We were experimenting with mobile systems where you had a backpack where the computer is literally on your backpack, so you can walk around freely without being tethered and so on and so forth. So we've tried a lot of different systems out there. This one right here was tethered to a computer. So this is really mainly geared toward the customer, or if you're doing some kind of outreach event for students or just people, what exactly is this mission itself? And we've used a number of different kind of technologies. This one requires handheld controllers. Others, such as the HoloLens, does not require, it maps your hands. So there was another company called Meta, which I'll show you a video on. This is not the Facebook Meta. This company used to be called Meta before Facebook changed their name. And they had an augmented reality headset as well, where they mapped your hands. And there's no what they call gestures. This company called Meta that designed this particular headset, one of the best field of views, more than 40, no, it was about 48 to 50% field of view, but because the headset was so clear that it felt like it was much wider. Now, this system here was designed specifically so that your hand gestures that you're used to is what you use to control the data and the information. For example, if you wanted something, you grabbed it. If you didn't want it, you toss it away, right? Just like that, you toss it away. But you look at HoloLens. HoloLens requires specific gestures. I got to pinch, I got to move, specific things that you have to learn. Meta, on the other hand, regular gestures that we're all used to. They based it on a baby's brain. If the baby wanted something, they grabbed it. And so that's how they programmed their system. So there's a lot of learning as we go on these hardware, but you can see it just gets better over time. So this one right here, we spent a lot of time on. This one is with the Meta headset, and this is a augmented reality system. So if you can imagine a designer or even a design review right here, you grab something, you explode all the parts out, you can walk inside, you can point to certain parts, you can put information on there, you can point to certain things, and they understand it. Right? If you can imagine looking at multi-sheets drawings where you have a harness that's 20, 30 feet long and it stretches on 15 drawings, you have to, in perspective, remember where each drawing and where each part is in your own head. With this, you don't need to. Right? So here, we just added additional information, what exactly it is. And this is, again, very rudimentary. You can put as much detail as you want. You can look inside the box and you can see each electronic slice of hardware, so on and so forth. As much information as you want. And you can see these are easy things you want to turn. You just use your hand, you want to grab it, she grabs it, closes her fist, and pulls it toward her. Any questions so far?
I have a lot of questions.
Okay. I'll wait. Let me show you one more. This one is, I don't have this video yet, but this is more of a screenshot. I'll explain a little bit about what we're doing here. This right here, we had a full-scale mock-up of the L-Cross satellite. And that's right behind all this virtual data. So if you look right here, this is the actual physical, aluminum struts that we built. So everything around behind this is real physical hardware. We overlaid virtual information right on top of it, one-to-one scale. We locked it into place, so wherever you moved, your perspective changes with how you move. The information is locked in place. We can touch something, the panel opens up. We want to install this box, we can touch it. Instructions come up on the right. If we want to see performance data, we can touch it. Performance data comes up on the left. Right? And so these are kind of the things that we were working with in terms of helping the technicians on the floor, of trying to show them exactly where hardware is, how it gets installed, what it would look like before it gets done. Right? Some of the other great aspects of this is that some of these pieces right here, these thruster booms, these thrusters, we didn't have physical hardware for that installed on this model, but you can see it here in the virtual information. So that also gives perspective to the technician of where something would be if it's not yet installed, right? Again, it gives more perspective to them. Now imagine this too, from a customer perspective. James Webb actually asked us to develop something quickly, but we didn't have the time yet to do it. But they wanted something, and we pitched it to them where they're back at Washington, D.C. talking to the customer. And we were back here in the high bay showing live information streaming, just like you see here. So we can open panels if they wanted to see it. We can overlay the information, even though it was built, but we can overlay virtual information. We can open it and show them virtual information if they wanted to see it, right? So again, that gives an extra dimension to the speaker, right? An extra dimension to the customer saying, wow, these are the right guys, right? It gets that impression that this is the right customer to use. And so those are kind of the soft parts of the convincing that I think engineering has lost quite a bit. We focus a lot on the technical parts, right? But there's also a lot of the soft skills in terms of convincing people whether or not your proposal is correct, your solution is correct, right? Whether or not your solution to a problem is on the right path. So these are a lot of the things that helps in that convincing. So I talked a little bit about this, but what are the obstacles to mass adoption? Some of these that are up here right now is really geared more toward the aerospace world, but it really does apply to just about every industry. One of the major ones is cybersecurity. How do you keep your data secure, right? If you're streaming it through Wi-Fi or whatnot, how do you keep that data secure? And so that's one of the bigger issues. And if you work in a classified world, you know, there's certain things that you cannot do. You know, as soon as they hear Bluetooth, they freak out and you're thrown out the wall, you know, the door. They don't want to deal with that. But we've made inroads where we've sat down with them, we've explained it to them, we've showed them the hardware, we've showed them the reason why we want to do that, and they're starting to crack, they're starting to open up, they're starting to understand why, and they're starting to work with us on how we can actually get these kind of systems in there, right, to use. So if they're starting to open up, you can tell that this is actually really good, that they're starting to realize this is really going to be the next phase of how information is processed. Antiquated infrastructure. As I was building our new smart factory, I realized as I looked in the ceiling that nothing has probably ever been touched for the last 50 to 60 years. And we all know that aerospace companies are not necessarily the best in terms of updating their facilities. And this is one of those things that we have to look at. If we're going to be using these kind of systems, it will require a lot of bandwidth and it will require a lot of IT support. And this goes back to one of those, this goes back to my previous slide of what is our strategy? If we don't have this strategy nailed down and every aspect of it ready to go to pitch to a company to say, hey, we want to do this, we want to use this. If we don't have it, one thing will pretty much ruin everything. So this goes back to that AR strategy. What is our strategy? Not just the use cases, but how do we maintain it? How do we get it in there in the first place? Data conversion. Now this is a bit of a sensitive topic. Now everybody knows creating content, drawings costs a lot of money, right? All of that is saved, it's revision control, and so on and so forth. So how do we get the data that we design, whether it's in Pro, AutoCAD, or whatnot? How do we get that into this virtual environment? Now, there are companies out there that realize we have this problem. Because if you can't get past this data conversion, it's pretty much a no-go for every company. Because that's a lot of money. That's a lot of information that they have. This is why you're doing this for this data. So there's companies out there right now. I forgot the name of this company that we work with, but I contacted this one company who said they could do this relatively quickly. So I had to fly down to my conference room. Didn't tell them what I wanted them to convert. I gave them a USB stick with a drawing in it. Gave it to them to go ahead. They converted that drawing, which was relatively complicated. They converted it in 3 minutes. I timed it. They converted it in 3 minutes and they put it in the VR environment. So we put on our headset along with theirs and we walked through it in the virtual environment. So they realized this is what needs to be done. Now, companies who make the design software like AutoCAD, Pro, and all these other, they're starting to realize it as well. You can start to see some trickling of the VR functionality in there where they realize that this is probably something that most of these companies want. So they add functionality in there to allow that whatever you design can be rendered in the VR environment without having to reinvent the wheel. Right? Nobody wants to sit here, like my interns, when they did this video, they spent hundreds of hours in Unity software redesigning this stuff. And we don't want to do that. That's not a cost-effective solution. Right? That's why this data conversion is going to be a very, very important part. And of course, the last one is the culture. There's a lot of, let's just say, a lot of resistance to new things out there. And this is probably one of those that's really futuristic, really science fiction for a lot of people. And they're like, I can't even grasp my head around it. So absolutely not. Right? So this culture part is going to be a really big portion that needs to be broken down. When I was building the smart factory, this is one of those things that I had to do. 50% of my job was marketing. It was getting people on board on what we're doing. We're not eliminating your jobs. What we're doing, we're eliminating the non-value aspects of things that you're doing so you can concentrate on your job. For example, we had technicians who spent 12, 13, 14 hours a day on the floor. I've spent many hours with them as well, and I realized they probably spent 4 or 5 of those hours looking for data, looking for information, not working with the hardware, looking for data on the computer, searching, because everybody says my information is digitized. It's in there. Just because it's in there does not mean it's easily found and it's useful, right? That's what we need to change. So this is part of that culture where we're trying to eliminate that. So we're trying to help you out to be a little bit more efficient from the culture aspect. So there's just these 4 things are the major obstacles that I see currently right now for mass adoption on a lot of these, at least big companies. Smaller companies would be more concerned with the cost of the hardware themselves, but large companies like the Boeings and the Northrops of the world, right? $2,000 headset is a blip, right? They can buy 100 of them in 1 meeting. So smaller companies, like I said, they might have a couple of other things that they have to work on. But what I realize is that these smaller companies realize a lot faster that this is probably something that they want to do because it can make them more efficient and save them money to compete with the bigger companies. Any questions so far? So you had a lot of questions.
Do well. I'm not even sure where to start, but yeah, this is Jeff Michelle. I'm the section chair. Fascinating talk. Thank you very much. I guess I'll start with a question about how you think this augmented reality or virtual reality relates or overlaps with what I'll call digital twins. It's model-based system engineering. It seems to me that there's great overlap. I can imagine a future that may be here today where you've got a piece of hardware that is described in so much detail that if the solar system and you were trying to debug something that was going on or going wrong in some hardware, this type of reality could be very beneficial, speed things up.
Absolutely. So I'm glad you brought that up. So in the space world, for those who are familiar with it, we have these test beds. We have been transitioning over the last 10 years to what we call high fidelity test beds. So essentially that's everything that's on the flight vehicle itself is on this flat sat spread out on a table, exact hardware, exact length of cables, exact cables that we're using. So that's a physical digital twin.
Yes.
For troubleshooting, for trying out the software uploads without, using up the life cycle of the real flight hardware. This augmented virtual reality system is just a aspect of how to troubleshoot and how to use that data as well, right? It's part of the whole digital twin strategy, at least in my view. Because right now, the digital twin is just on a laptop. Right? It's what you can see there. Now, again, if you can take that information, like I was talking before back there before the meeting started, was imagine if you can take test data, and this company did this for us just as an example, where you take wind tunnel test data, and I gave them some wind tunnel test data along with locations of where each of those points were. They took it, they put it into their virtual reality system, and they rendered it in a 3D environment. So now I can walk around this physical hardware and look at each point where this wind tunnel test data is. Right? So I brought some engineers in, like, oh my gosh, look at this, right? Because sometimes they realize I don't know where this point is, and I have to look at a drawing and correlate the two together, and in their mind, make a 3D wanted to, they can touch a point and give information. So there's a lot of aspects of what we use this thing for, but digital twin, absolutely, this is just one portion of it.
Yeah. So another perhaps similar question, but maybe closer to reality, is you mentioned at the beginning of the talk of, pilots training, obviously, this kind of virtual reality. Well, what about future or current systems where weapon systems, autonomous vehicles are now halfway across the world being used for whatever purpose? But somebody, say here in the United States or at a different base is in control. I could imagine all sorts of bandwidth problems, latencies, in the command and the action that results. But it seems like you could mitigate some of that through, say, AI, where on board the platform is AI that's doing most of it. But at some point, in whatever is going on, a human needs to say, yeah, I can see, in my virtual world, using the sensors that are on board the platform that we need to do that or we shouldn't do that or whatever. Is that here today? Is that coming? Is that it?
It's already here today.
Yeah.
For people who play games, right?
Right.
Your character on the game, a good portion of it is AI control, right? You're not controlling just about every function of your character. It's already here, right? And it's just how do you take it from an entertainment world and put it into, like I said, a defense or any other kind of industrial world. It's there, it's done. You just have to solve, again, some of the issues like security, IT infrastructure, the bandwidth, latency, those kind of, and it's easily solved.
I'll just make one last comment for the moment. I was actually involved with the L-Cross impact. In fact, as I told some of your former colleagues at our awards event, because they sat at the same table as I was on Mount Wilson with a Raytheon infrared camera using a 60-inch telescope to try to observe the impact.
There you go.
Of course, like everybody else around the world, we didn't see anything.
Right.
But one of the challenges we faced was we had a direct line of sight communication system to Redondo. We were trying to send our data directly to Northrop Grumman, but the security on the network prevented us from doing that. So we ended up having to send it to the Carnegie Observatories.
Yes.
Pasadena to get it to NASA.
Yes.
So anyway, that was a fun night. We probably could have been inspired by your intern's work as we were desperately trying to see whether we
That's correct.
had observed the impact. So
I built that one from the ground up.
yeah,
So I know that program is.
yeah. Thank you.
Sure, absolutely. Any other questions? What do I have?
Yes, in your experience, if you're going to be, say, distributing these VR or AR headsets to a team, how much IT overhead and human support do you need? Because I work with luckily not mine, but I work with some organizations where they're still struggling to share a PDF in Microsoft Teams, and I can't imagine doing a design review with the client and say, okay, step one, pair your HoloLens with your Microsoft Teams account.
So let me just say this comment. I loathe Microsoft Teams. I don't know if anybody else.
That's absolutely correct. This goes back to some of that mass adoption where we have to make it as simple and as easy as possible. And when I was doing this AR VR, the direction I gave my team was model it after Amazon, right? Put in things, make it so simple that these are things before they even think they need it. Such as, I don't want to sit here and need a technical person to help, set this thing up, hook it in and use it. It should be as simple as I put it on, I turn it on, I click one button, I'm in there, right? You want to use systems that's very intuitive, right? I don't want to have to teach the users, you got to use these kind of gestures in order to, open something up or to move something, so on and so forth, right? That's where companies, well, Meta's gone, but another company bought them out. But this is where they actually hired neuroscientists to really look at how the brain works and process, and that's how they design their systems based on normal gestures. So people do realize that that is a very big aspect in terms of acceptance and adoption. And there are companies out there that's streamlining. Microsoft HoloLens, for those who have ever used it. We had the old generation, but the newer generations are much easier to use than previous ones. So even the ones who are making the hardware is realizing that if they want to be adopted, it has to be very it's getting there. It's not quite there yet. I mean, this is more on an enterprise level and more for people who are tinkering around. So as of today, you probably do require more tech support than you probably have now in order to implement these systems. But this is where you have to weigh out what exactly you're trying to use these systems for. If you're trying to convince a customer that you're the right person, and this is one of those where it will push you over the top because you're giving them a experience that paper just can't give you, then that's one thing. If you just want to read a document, you know, that's another thing. So right now it's really based on what exactly you're using it for.
So as the hardware continues to evolve in the future, the old versions of the hardware still would be supported as the new versions roll out, or how quickly is the old hardware will be outdated or become antique?
Right now, it's not moving as quick as, say, your iPhones, right? Because that's a more mature technology. I would say right now, every 2 to 3 years, you see a new generation of headset that's significantly better than the previous. It's not going to be every year right now. And for example, like the Microsoft Hololens. The Hololens has been out there for years now, and they just released a new one probably 2 years ago. I never got my hands on the new one, but the new one is significantly better than the old one. A lot of these companies that I talked to, my request to them was if we were going to use a mass adoption, the number one thing was that hardware and their software has to be agnostic from one another, right? You cannot lock me into the software with that hardware, right? Because then that pins me to always use you, or if you had a problem, then this hardware is hit, and vice versa, right? So those are things that people have to realize and express to the manufacturers that, hey, like your question, right? I don't want to be stuck with this. I don't want to be stuck with unsupported stuff. Right? But I don't think that they're going to just not support 1 or 2 generations prior. They software, for example, they still support 5 or 6 generations ago, 12, 13 years probably. So I think for right now, we probably don't have to worry so much about that. We'll probably have to worry more about that as this gets adopted more and more, and newer hardware comes out faster and faster. Another question?
I'll take that. Somebody else has more questions? I still have more.
Sure.
And I'm sorry to go off the deep end here a little bit, but I just want to get your thoughts on some things. So there's a lot of discussion these days about the so-called metaverse and what that really means and where it's going. And it seems like this overlaps with what you were talking about. So I've heard people speculate that in the not too distant future, we'll have virtual worlds where people can buy and sell property, whatever that means, in a virtual world, and people have experiences. Really, I'm not sure what it means exactly, but it sounds really interesting. Some people think that in this virtual world, we could have stock markets that really don't have a limit on the value of things. Again, it sounds very interesting, but I also have to say that in order for this to really have any value to the human experience, it has to be connected with some sort of virtual reality, maybe some sort of augmented reality video games of people that actually live in that world.
That's a big thing, right?
Yeah.
Right now, if you really look at the metaverse, it's just a new coin term. I have young kids, so I see my kids playing on Minecraft and all these, games and everything. It's existed for a long time, right? I mean, not with physical money, but Minecraft money,
Yeah, that's
whatnot.
sounds a little bit different.
Yeah, but I mean, it's a similar concept, right? But now you're taking it to real world dollars. But take, for example, I talked with this one company, and they provided a virtual design system where you can be anywhere in the world, you can put on a headset, and you create an avatar. The hardware can be pulled up. You guys can have discussions and things, see each person, and you can allow who can talk. It's almost like work, simulated Zoom person. And you can actually design the hardware real time with them in this environment. Oh, I want this, let's add this in, they can move things around. So one of the questions that my team and I asked them was, how do you, hold on to revision control of these kind of drawings as you're making changes and so on and so forth, right? And they haven't really thought that far through yet, but these are things that they're eventually going to get to, right? So these virtual environments, per se, from an engineering standpoint, could be that where you're not designing in front of a computer on a phone trying to describe to one another. Now you can be in a virtual environment, do it real time. So it's getting there.
Yeah. Well, and I think a lot of these tools need to be automated, right? But otherwise you'll never have enough time to really describe this reality before, it becomes relevant or nobody cares or whatever.
That's correct. So it's just a matter of.
That's the question.
Yes.
Yes, I did, and he said that not unless you want to.
So, Felipe, do you want to say something?
Hi, yeah, I was just offering to comment on metaverses, as that happens to be my livelihood for over 30 years. I have built 6 metaverses over my 30-year plus career as a builder of multi-user virtual worlds as a VR veteran, and I'm currently building my 7th. So if there is, there unfortunately has arisen a Babylonian confusion of biblical proportions around the word metaverse. And if anybody wanted to hear my my take on it, given that I've been building them for 30 years, I was volunteering that, but only if there is, if it's topical.
It certainly is for me.
Yeah,
Okay.
Felipe, you and the many, you are the next speaker, so you're welcome to mention a little bit about that.
Okay, so
Not yet. Right now, it's still Dennis.
I understand, and I wasn't presuming to start my presentation. All I will say is that the confusion around metaverses is extremely unfortunate. It's caused by some big players in the IT industry, and the meaning of the word metaverse has been non-controversial and non-confusing for 30 years. It has always meant a persistent social virtual world where you can do almost anything that you can do in the real world, including working, playing, creating, dwelling, etc. And now, as Mark Zuckerberg and others have seen fit to call whatever they are doing with the next generation of mobile internet, and that's what they are now calling the metaverse, singular. Whereas for the first consumer-facing metaverse was called Habitat, and it was launched in 1985 by Lucasfilm. And so after that, in 2003, there was Second Life, etc. There have always been metaverses since before the World Wide Web, and so it's important to realize that there is a semantic land grab underway from some big players in IT, and they are forcing people like me, whose livelihood has been in building metaverses. They are forcing us to find a new name for what we have always used as as our livelihood. So. And I'll stop my rant here, but there's obviously much more to that, but I just wanted to give or share that little bit of perspective.
Actually, I asked Felipe a question before that is he working with Facebook on Metaverse? But then he says that he's building his own. So he is building his own Metaverse. As you heard, he has been building several already. Yeah, very
Correct.
exciting. And he is working on the virtual moon, which is another virtual reality stuff.
So that's why.
Correct. And which also has tie-ins to the metaverse that I'm building. And but to kind of capstone that, whatever Facebook is talking about when it is talking about the metaverse, ignore it because they don't know what they're talking about, and take it from somebody who has been building metaverses for 30 years. They are confusing people. It's horrible. And that they're not being internally consistent, etc. And so, but I'll stop my rant here.
I mean, I agree. Metaverse is a very general term. So these are specific cases that can be used. It's just a virtual environment of how you perceive and utilize data. That's my point.
Yeah, unfortunately, I've seen similar things happen in other fields.
Yes.
Somebody perceives an opportunity to make a lot of money, so they basically take a term that has a distinctly different meaning. Maybe it overlaps when they use it, and then you have to go back and spend a lot of time explaining why there are differences. So yeah.
But sometimes it does help where if they coin the term and they realize it's a virtual environment, they think of metaverse but not quite there, right?
Yes.
So it kind of helps them accept it a little bit more versus just really stuck in the industrial world. And like, well, I have nothing to do with the industry, so I don't know what it is. Yeah, but it's a double-edged sword.
I have other
Correct.
questions related to factories of the future.
Yes.
I probably don't have time to get into them, but
Up to you, Ken.
No, I'm fine. I'm here. Go ahead.
okay. Well, I mean, I'm just interested in hearing more about the factories you worked on. Sure. Clearly, that's, I'm a space guy, so the whole space world is being automated. The Industrial Revolution is finally coming to space, but it's doing so in a highly automated way. So your experience in that area is certainly a hot commodity right now.
So I've spent 20 years building spacecraft, developing production, testing, launching. And I'll tell you right now is that a lot of what we do is very manual. It's very manual. A lot of people realize that it's still the best and only way to do it. I don't subscribe to that philosophy. For example, when I built this new facility, it was a multi-phase construction where it wasn't just building a facility to make production more efficient, meaning, I had the correct gases, there for cleanliness control and so on and so forth, and outlets and so on and so forth. Not just that, but also you have to integrate some of the technology, such as, for example, we purchased some of these KUKA automatic guide vehicles, ATVs, right? Omni-movement, omnidirectional. Right now, what we do, we either push manpower or we use air bearing systems, right? And let's just say to move a vehicle right now, a relatively large vehicle, right now requires 20 people, air bearing system, about 5 days to set up, move, and break down, just to move it however many feet you want, right? Just for one, we do multiple. That doesn't even include moving from building to building. So that was also part of the physical, was to remove that moving from building to building, so internal. But we added those robotic systems in there to kind of help a lot of these manual labor work that doesn't really require it. So it hasn't changed in 20, 30 years. So I think it's the time to really look at what other industries are doing and incorporate that. In addition to that, too, one of the major things that everybody had was, how do you process the data that's coming at you? Just because the data is in some SharePoint or in some server, that doesn't mean that you can find it and it's usable. And so I had my team look at other industries. For example, you look at the malls, simple ones. Now they have interactive maps, right? Before it was just paper, right, on there. Then you look at airports, right? You look at all the status, departure, arrival times, but there's a lot of data behind show what the people really need. And so that's what we designed in, where technicians would see certain things and they would be at certain stations. Manufacturing people will see certain things at certain stations. Engineers will see certain things. The business people will have, real-time data, almost like a stock market, where as items come in, items are paid for, it shows it booked, it did not book, so that, managers can say, oh, okay, customer, this is how much I spent this year, or so on and so forth. So now all this data is real time. So what does that do? That eliminates a lot of, I don't need stats meetings, right? Just to say, how are you doing? I can see it when I come in. Oh, there's only one person read. I'll just call that person and leave the other 11 to go do their jobs. Stay brief. Exactly. And so we incorporated a lot of that data because that really affects just about everybody, right? And then we also included we called it the user experience for either executives, guests that come into our factory, digital boards where people are sitting, just like you do at the mall, right? So on and so forth. So we added all that together and create one entire digital experience from beginning to end of a vehicle. We incorporated that all into the factory. So that included spending extra money on infrastructure, and that infrastructure included additional capacity for as things progress, you're going to use more and more bandwidth. So we included all of that together. So did this factory cost a little bit more than it should have? Yes, but will it pay off down the line? Absolutely.
Very good. Thank you.
Yeah.
Well, I think we should thank our speakers.
Yeah.
Yes.
Yeah, thank you so much. Thank you.
We have appreciation, right?
Got that.
Presented.
Thank you very much.
I really
Appreciate it.
talk.
Thank you.
Take a picture. Please, 1, 2, 3. Sorry. One more. 1, 2, 3. Thank you so much again.
Thank you.
Yeah.
All right. If you guys have follow-on questions, feel free to contact me.
Yeah, we will offer the contact information.
Not just AR, space in general, so on and so forth. Yeah.
Your contact information is in the meeting notice, I guess. Or...
Yeah, yes. Yeah. So originally this event, we try to combine. People can bring their headset, game PC. But I guess the parking here Saturday is not very easy. So we'll keep trying to find a better location. But our next speaker is with Virtual Moon.
So we're going to have to leave, but
Oh.
I think I'm going to join online from our.
Okay.
We're getting ready to go to our next.
Thank you so much, Jeff.
destination. So yes, I
Thank
look forward to connecting with the second part of it. It sounds good too.
Yeah, it's very exciting.
Okay.
In between, originally there is a Mars driving software, Mr. Alan Chen, but looks like he's busy today. At the end, if we have time, we can do some demo here. Okay, so Manny, Felipe, are you ready?
Yes, I'm here.
Go ahead.
And so am I. And Philip is ready.
Yeah, go ahead.
So, Manny, do you share your screen, or how much time do we have, by the way?
About 30 minutes.
1-3 or
Oh.
3-0?
3-0.
Okay, great. So we can dive right in. I'm sharing my screen at the moment, Manny. Did you want to start, or shall I? Or
Just a second, because we need to connect you to the HDMI. Let me do this. Just give me 1 second. We'll turn on the alternative projector.
Many has.
okay, so tell us when we.
Yes,
should-
because the HDMI cable is too short. So we are trying to do the remote projector.
Okay.
Almost
Okay.
there.
It's fine. We're standing by, waiting for your
Almost.
starting shot. No, there was nothing
Can I stop share for a minute?
Can you hear me?
Yes, we can hear you.
No,
Okay. Because, all right, this is what I'll do. Just give me one more second. The plan A doesn't work, so let me work on plan B,
Sure.
which okay. Okay, can you say something?
Something?
Yeah. Can everybody hear?
Okay,
Okay.
I see. Yes, I see that it's on the screen. That's great. Okay, so that is Manuel Pimenta and I, Philip van Nedervelde, we are here representing flying the flag of the Virtual Moon project. Virtual Moon is the current incarnation of a project that was started by Manny many years ago, and that project was called Lunar Explorer. And can you remind everyone when Lunar Explorer was published, Manny?
Sure. So Lunar Explorer went on sale in 2004, and it was even though back then there was no virtual reality hardware or consumer affordable virtual reality hardware, it was built as a fully immersive, interactive 3D virtual reality experience. And again, we put it on sale in 2004. And it ran on standard home computers and laptops as long as they had a video card.
Right, so Lunar Explorer was a very ambitious project ahead of its time and aiming to provide consumers with the next best thing to experiencing space missions and the moon, short of going there and putting on a spacesuit. So the Virtual Moon project today seeks to do all of that and go beyond by updating the technology, which is now far more accessible to consumers, and by delivering all of that lunar goodness via the World Wide Web and open web standards enabling virtual reality and augmented reality via the web. Specifically, what you are seeing on the big screen is our version, it's still work in progress, of the Tranquility base of Apollo 11. And it shows the kind of realism that you can achieve in WebXR using a programming environment called Babylon.js, which is an open source framework for the creation of WebXR compliant VR and XR or AR scenes which is a Microsoft product, free and open source. And so there's also another one by the Mozilla Foundation called A-Frame, which we used for some time, but which we abandoned in favor of Babylon.js because of the superior performance of Babylon.js. Not only does Virtual Moon update Lunar Explorer on all the parameters that I just described, it also improves it by enabling multi-user access to all of this content. The project is currently in an early phase. We call it the Virtual Moon under construction phase, in which we are producing a set of demonstrators, such as the one that you see on the big screen, that allow us to show off the kind of technical and experiential features that today's technology allows us. And so, for example, in this scene, aside from showing off the relatively high frame rate, GPU accelerated graphics, if there's a GPU available, of course, so we're showing the ability to have dynamic shadows. I'm trying to switch on the sun controller, but it doesn't seem to want to work. So let's blame that on Mr. Murphy paying us a visit. So there's multiple other demos that we have in varying states of readiness, including an Apollo 11 landing experience, which is over here. So I think I must restart it. So the Apollo 11 landing experience is, as the name suggests, I will restart it here. The idea there was to recreate the Apollo 11 lunar landing and to experience it as if you
the approach phase, everything looking good.
As if you are standing
Altitude 5,200 feet.
on the moon before it actually lands. And so we basically have the final stages of the approach and landing of, and I'm hunting for to find where they are, because obviously, given the angle of the sun at the time, we cannot see much of them while they are approaching.
They're right to the left of the sun.
Altitude 1,600.
Right.
I can see it now.
1,400
Yes.
feet, still looking very good.
So you see a little bit of the plume there. And so this too is work under construction, and where are the controls for flying along next it? Are they activated in this version? Okay. So I don't know if it's visible for people in the room, but the lunar module is over here, and you see it standing kind of on its exhaust plume. So remember that all of these experiences are accessible thanks to WebXR. All of these experiences are accessible via smartphone, tablet, PC desktop, VR headset, and later also even in AR. So I'll kicking up some dust.
100 feet, 3.5 down, 9 forward.
So this is a real-time rendered scene.
75 feet, down a half. 6 forward. 60 seconds. Down 2.5. Forward. Forward. 20 feet down, 2.5. 3 feet, 2.5 down. Shadow. 4 forward. 4 forward. To the right. Down a half. Forward. Right. Okay. Stop. Hold control both autos, engine command override off. Engine arm off. 13 is in. We copy it down. He's going tranquility base. Eagle has landed. It's like tranquility. We copy you on the ground. You got a bunch of guys. Got to turn blue. Reversing again. Thanks a lot.
Okay, if we could cut out the echo, that would be great. Okay, thank you. So this is the Apollo. We still have an echo. Somebody has their mic open. Okay, thank you. No, we still haven't corrected the problem. I still hear an echo. So could everybody please mute their mic? Okay, I think we got it now. Thank you so much. So that was the Apollo 11 lunar landing experience. I don't know how much of my audio commentary you were getting in a way that was comprehensible because I was speaking over the Capcom exchanges between the astronauts and and Houston, but I was basically saying that the experiences that we are producing for virtual moon are all accessible from the web, any browser, but also from any device except gaming consoles at this moment. So you produce the virtual experience once, and then it's accessible for anyone, whether they have a smartphone, a tablet, a PC, a Mac or a Windows machine, or a VR headset, and later even AR headsets. So that is a big goal of the Virtual Moon project is educational. And so another part of the Virtual Moon project that I'm showing you now is the South Pole. And so over here, what we did is we went ahead and found the data from the Lunar Reconnaissance Orbiter, and we imported that. And then we built a system where with WebXR and Babylon.js, where we have dynamic shadows, so we can correctly, with astronomical accuracy, move the sun around the south pole of the moon and see how the illumination angle changes the view of the landscape. Here we have an overlay where we show the deposits of water ice that have been identified, including the at the bottom of some craters. And we also have labels overlaying the lunar landscape. So the idea when Virtual Moon will be complete, which it is not yet, is that we will offer to anyone the moon virtually. That's obviously why it's called the Virtual Moon Project. And we intend to do that with maximum quality so that it's just as good as being there. You will be able to land virtually anywhere on the moon. With dynamic shadows, you'll be able to take field trips to the moon, multi-user enabled, and it will be accessible possibly with at a slightly lower quality in terms of rendering to anyone. The overarching goal of the project is education, and so we want to offer the moon to even a 12-year-old kid living in a provincial town in India who has to beg his father for an hour of time on his father's smartphone and then use that smartphone to have a visceral experience of the moon by means of the Virtual Moon Project. And so I've mentioned some of the more important parts of the project. We also will have a professional version of Virtual Moon, which will be called Virtual Moon Pro, which will be used and offered to the space industry for mission planning and for more pointed applications such as, okay, I'm going to have a lander with photovoltaics on the South Pole. It will land on this point. Now calculate for me the path, the trajectory where I will have maximum solar illumination during my transit from point A to B, so that we can optimize for the sunlight, for the illumination on the South Pole, which can be tricky given the very low angle of the sun at that point on the moon. So you don't want to have your little rover stuck somewhere in deep shadow. And so that will be Virtual Moon Pro. With regard to rendering, I need to mention that we intend to offer, this will probably be at a little cost, certainly initially. We intend to offer and apply the technology known as cloud rendering, whereby we can offer 120 frames per second frame rates with graphics that are real-time ray traced at that kind of very high frame rate by doing all of the heavy lifting in GPUs at data centers rather than in the underpowered devices in the hands or on the heads of end users, such as, you know, smartphones for right now and for the foreseeable future. They just cannot do ray tracing at 120 frames a second, even on a flagship smartphone. But and an Oculus Quest 2, now a Meta Quest 2, I guess, cannot do that either. However, by means of a good internet connection, if you have an internet connection of 5G bandwidth or better, that is enough for us to pipe those very juicy graphics to your underpowered device and display them interactively at a very pleasant frame rate, thereby providing you with high frame rate ray traced graphics on your on your underpowered device. This is a big development that NVIDIA and Microsoft and even Google are working on to improve the quality of graphics and the photorealism of graphics for end users with underpowered devices. Eventually, you did hear me mention game consoles. So eventually, we will also seek to provide access to Virtual Moon on game consoles. Now, for those who joined us before this presentation and who heard me rant about metaverses, the technology that is being used in Virtual Moon is actually technology that we are developing and have been developing for the metaverse that we are currently building. I cannot say much about that project yet because it's still in stealth mode, but all of the technologies that are going to be state of the art for Virtual Moon are there because we can. I'm a huge space buff myself, and so when Manny Pimenta and I found each other, I was very eager to make use of the massively multi-user and other capabilities of our engine for metaverses, and to use that in Virtual Moon. Manny, maybe I should shut up for a moment and let you mention some things that I may have forgotten so far.
You've covered all the important points for sure. I was wondering if anyone listening has any questions at this point. All right, if not, we can keep talking. One other thing that Philip didn't mention is when he was talking about calculating the illumination on a traverse of the lunar terrain. It's not just about calculating the path, but also calculating the timing. And we already developed a high precision orbital mechanics module for the Sun, Earth, and Moon systems. So we can show you what the illumination on any portion of the moon, any spot of the moon is at any instant in time, in the present, in the past, or in the future. So one of the cool things we're going to be doing with that, for example, is you can be standing on the moon while there is a solar eclipse going on. And from the moon, you can watch the shadow of the moon being cast on the Earth during the eclipse.
That is correct. I wanted to riff off of that by mentioning that the real-time engine or the real-time aspects of Virtual Moon also will enable us to do the following. And we don't know if we'll actually do that with the project that is aiming to image the lava tunnels on the moon. But the fact that Virtual Moon runs on the web will allow us to do the following. When there will be a swarm of robots that are entering and using LiDAR to in 3D scan lava tunnels on the moon, we will be able to capture that telemetry in real time and display the buildup in Virtual Moon in real time with multiple users there. Basically, you will see the lava tunnel that is being explored come alive, so to speak, or to see the progress of the scanning as the geometry and textures, if any, depending on lighting, come in from the moon. And so that will be that. I think that will inaugurate a way of enabling people to experience lunar exploration in real time. So not only will we be able to do that with the spectacular example that I just described, but also in virtual moon, you would be able to, for example, robotically or remotely control a robot that is roving around somewhere in the moon, on the moon, and see through the eyes of that robot, and you will be able to use virtual moon to remotely control it, and also see a virtual reality representation of the goings on at lunar bases. So it's a very exciting way of connecting the real moon with a virtual representation, a digital twin of it, if you like, in the form of virtual moon, because NASA has been spearheading the notion of digital twins ever since the physical replica of Apollo 13 was key in bringing the guys, the astronauts, safely back home. Digital twins are the logical extension of that. And one of the ways to understand the Virtual Moon Project is that we are in the process of producing a full-scale digital twin of the moon in virtual reality. While we are talking, I'm also showing you, or on the big screen, you can see that someone, Helen of our company, joined me on the scene, and she's emphatically nodding her head, so saluting next to the US flag. Thereby showing that we have the multi-user capability for this scene up and running. The Apollo 11 landing experience really should be experienced ideally in a VR headset, because it always puts a lump in my throat, and it's a very emotional experience to see that historic moment recreated with such fidelity, but experienced by your disembodied viewpoint standing on the surface of the moon. With that, I think we've given you a great taste of what we are working on with Virtual Moon. I've mentioned that it's a primarily educational project, and that it also will have a professional side to it. I don't know if what we have shown prompts any questions at this moment. Maybe, Manny, we need to be looking in the chat space. I don't know if there's a moderator who will ask us the questions by voice, or whether we are supposed to look in the chat.
Yeah, I'm looking at the chat now. There's no incoming questions so far.
Okay. How are we doing for time? Do we still have more time? We have more stuff to show, but we need to know whether we're going over time or not. I don't know if there is a moderator. Is there a moderator in the house?
Yeah, I see Ken is there.
Okay.
Ken, can you hear us?
Yeah, I think what happened is that's what right? So.
I can. If you're speaking, we can't hear you. We heard you a
Can you
little
hear
bit
us
before.
now?
Yes, yes.
What happened is we use a brand new projector, supposed to have a microphone. That's why you hear the echo.
Okay.
So we are turning it off.
All right, but to Philip's question, how are we doing on time?
Time is good. Just give us 1 second. So it should be okay now. Okay, the echo should be no more.
Yeah, it's
So,
gone.
Can you hear us, Manny? Felipe?
Yes, I can hear you.
now it's part.
Okay, so if we have more time and unless Manny objects, we can show you a.
Can you hear us?
Yes, we can hear you. Can
Okay.
you hear us?
Yeah, the problem is the new projector, the microphone control. We need to figure that out. Actually, we have a question. Mr. Stewart has a question. Time-wise is okay.
Okay, we're ready for your question.
Hi, I'm Doug Stewart. I'm a documentary filmmaker. I was intrigued with your simulation of landing on the moon. The question I had was whether there's going to be the ability to incorporate actual footage that was on board Apollo 11 and other Apollo craft that landed on the moon. In other words,
So yes, the answer to that is not at this moment. So what we did integrate is the
soundtrack.
The audio, the Capcom audio, and that is of course timed to coincide correctly with the virtual visuals and their animation. But what we hope to do in the future is to do a recreation, a loving recreation of sorry, no, Helen, this is not the right one.
Okay.
This is the right one. Please get me that code. So what we intend to do is to recreate all of the hours and hours of EVAs of the Apollo missions and use technology called videogrammetry and NERF by NVIDIA to recreate all of the astronauts walking around and driving around. I think there is in total, I don't remember at this moment how many hours total over the 6 missions that were on the moon. But the idea would be that we would use all of the photography and videography that was shot during those missions to recreate those missions. And that would enable you to either be a fly on the wall and at a disembodied viewpoint, experiencing those historic moonwalks, or to experience them through the eyes of one of the 2 astronauts, and maybe also enable you to take over the driving of the lunar rover and experience that in virtual reality, but with correctly simulated lunar physics. What you're seeing in the on the screen at the moment is a work in progress where we are building Selene, which is a city, which is a lunar city that would hold up to 5,000 people. And the red elements that you see here, it's a very long tunnel that would be excavated literally in the top of Mount Malapert, which is the tallest mountain on the south pole of the moon. And then the bulk of the city would be inside of this cylindrical volume called the atrium. And all of that would be underneath the top of Mount Malapert, which you see here. And again, which we can illuminate from various sides. And so that's also part of the Virtual Moon project. Just for your information, what you see here, these little, this line of white dots, they actually mark out a path, the fastest path from the top of Mount Malapert to the South Pole, which is right next to Shackleton crater over there. So, and another thing that you can see here is, you see it with the blue trail here, is a SpaceX Starship that just blasted off from one of the launching pads in green here on top of Mount Malapert. So this is a scene that we're working on, which will be part of Virtual Moon. And the interest here is that the Selene city, which is an idea of Manny's, of Manuel, here with us, to engineer a city on the moon that would be engineered to such a level of detail and accuracy in terms of space architecture that at some point in the future, the designs would be so, the digital twin that we made in virtual reality would be so good that it can be, it provides the blueprints for the building of an actual Selene in the top of Mount Malapert. But did I answer your question with regard to our intended usage of video in Virtual Moon? So
yeah, I understand what you're trying to do. I think that's
right.
Rather noble.
Now, it goes without saying that we will probably also provide embedded links to just 2D regular video of the Apollo EVAs.
Sounds good.
Yeah. Any other questions?
Any question? You mentioned about the pro version. What is, you mentioned this is for education, but you also mentioned about the professional version. Now, what is the main purpose of the professional version?
The professional version, the goal there is to make money, and to do that is by providing space professionals with a tool for mission planning, but also for doing using an accurate digital twin of the moon for other aspects, such as when things go wrong, and to figure out solutions using Virtual Moon as a digital twin. And specific examples are for example, is our outreach aspects for projects such as the 3D scanning of lava tunnels on the moon, as I've mentioned. But the primary goal is offer a mission planning tool, and also for example, after you've, this is, I'm moving my viewpoint so as to show the landing of a SpaceX Starship on one of the landing pads, landing zones of Mount Malapert. And so the other use case is the one that I described, where okay, you actually have landed your rover on the moon, and maybe it's not at it didn't land exactly where you wanted it. So now you need to figure out the best path for your rover to reach certain points that are the targets of the mission in such a way that it still has enough juice hitting those photovoltaic cells on its back. And the astronomically accurate recreation of the moon, including the real-time ray tracing, etc., would enable us to use Virtual Moon Pro for very accurate calculations as to finding a path with maximum energy production by the photovoltaics. Manny, would you like to add any other use cases or uses of the Virtual Moon Pro?
Yeah, it's also, it's a natural way of sharing the information sharing the mission with the public. A lot of these companies that are involved in lunar missions have an interest in having the public know about it. So as a tool to inform the public about the mission, and also to be able to share, as Philip was describing earlier, in real time, as data is being collected from the moon, it can be sent in real time to the Earth, and users on Virtual Moon can see or visualize the data coming in real time as it comes in. So it creates a very strong personal connection with individuals in the public with these missions, which it's probably beneficial. I mean, it's likely beneficial for the ongoing support of this next phase of exploration of the moon.
Indeed.
Okay, very good. Any more questions? Because actually we promised people that we'll have some kind of networking session. Although not many people bring their own PC or headset, we do have Karen bring the headset. So we'll leave a few minutes, and after the presentation, if we have a Mars driving software here, so you can play around. So thank you, Felipe and Manny, and this is amazing. So last time you showed us the link for the Lunar module. Is it still available?
Yes, for the Apollo landing experience.
Yeah.
Yes, it's still available.
Okay, can you share with us again so people today can take a look?
Are you referring to the landing experience or to the Tranquility base?
The one that you kind of offer to public, we don't want anything proprietary, just something that last time you say attendee can.
Well, you can check out both, keeping in mind that this is still a work in progress, but we have, let's give them both, Manny. So there's the Tranquility base, which is our recreation of the Apollo 11 landing site as it should be today, if the flag was not blown down. And so that obviously is missing the descent stage. The ascent stage of the lunar module. And then the other one is the Apollo 11 landing experience, which has the entire lunar module all the way down. Basically, it's the approach and landing and the last 2 minutes and 40 seconds or so of the flight all the way down to the lunar surface.
Very good. Yeah.
We're sharing those in the chat, correct?
Yes, yes, please.
I accidentally.
Okay. So, and if you have any further questions, don't hesitate to hit Manny or me up by email, and we'll be happy to field any questions you may have, or explorations of collaboration if what we're doing might mesh usefully with what you're doing.
Okay, great. Thank you. Of course, we'll provide you information so people can ask you further, further questions. So thank you so much. Thank you. Appreciate it.
Our
Thank you for
pleasure.
inviting us. Thank you for inviting us.
You're welcome to stay online, because what we'll do in the networking, although it's not optimal, but it's kind of also experimenting for the next VR event. Actually, initially we planned to have several exhibitors before pandemic, but it didn't really work out. Now people just gradually going back to the in-person event, so we kind of call it in between. You know, some people still kind of tied with Zoom, but they also hesitate to come out, you know, for gathering. So, but we're still experimenting. So we are going to do some casting. We'll try your link and cast on the screen and some other things, and for do the network session. And so you're welcome to stay a little bit, but if you're busy, really appreciate it. We'll see you next time. And we also set up this Mars driving software. This is still 2D, but it's kind of fun, developed by Mr. Alan Chen. And there is a VR mode, but unfortunately VR mode we cannot project on the screen yet. So right now we officially enter in the networking. So you are welcome to come to the front to play the Mars driving software, and then we'll try to test some casting of the VR headset on the screen. Thank you so much. Thank you. Yeah, so here I have the, you're welcome to come here. You have to go, welcome to the, so you can take a look of the Mars traffic software, and I'll try to cast something. Go ahead, this driving software, they can use the joystick. Has to be on driving.
The thing that we were doing.
Yeah.
Washington.
Well, this is original idea, so people with PC and have fun. I think it's,
Yeah.
do you really want, because people say pandemic is better not to share.
Oh.
Okay.
It's covering my eyes, not my mouth.
Yeah, you can try.
Yeah, Ken, do you want to like try and walk through it? Do you want to do it yourself? Or?
Yeah, originally I want to do it myself, test on the screen.
Can we start to break that down?
Otherwise we have to
Oh,
create.
yeah.
So initially what is trying to do? Oh, take down, yes. This is what I'm going to do is actually it is. Because you can actually cast whatever on the VR thing onto the.
Facebook one, right?
Yeah, this is.
Oh, okay. But it's not.
Let me see. So we ask you to define an area.
You can't see it up there.
Not yet, because it asks me to start
from the beginning. Yeah, once I test, it should be able to hear. Okay.
We have an Oculus, first version, but yeah, you have to identify an area and choose your things and fun. But we just played like Beat Saber, so play Beat Saber. Yeah, no, I like that. We were all just playing Beat Saber. Yeah, yeah. It's kind of fun, right? I want to play Beat Saber. I mean, it's fun. But yeah, get different levels.
So basically, so now you should be able to see.
What is this? What is this?
This is whatever I see casted on the screen.
But where are you?
This is like a resort.
I'm sorry, it's a what?
Resort.
A resort, okay.
Yeah, but I can change to any other place. You know, different kind of settings. Let's see. So you can see there's also the meeting VR. Can you see it?
Yeah.
This has spatial. This is actually initially I tried to see if we can do it with some of the attendees online or here. We can do this VR meeting, but maybe the next time. And
Right. Yeah, I don't know. Yeah.
this is Oculus 2.
Oh, okay. So this must be the version.
So this is a mission ISS. This is what Dennis said. You can kind of grab things, you know. So if you wear this, it's just like you are right next to it.
Living in space next to it?
Yeah.
Floating out in space, floating words. Yes, yes.
You're gonna do a repair.
Oh, yeah. Yeah, right.
Did you use a powerful computer to get these?
You see, I'm trying to use
Yeah, you can download apps on your phone and upload them to the Oculus from the phone.
yeah, try to grab.
Yeah, so where the headset to see everything. That's one of the reasons why they have to put a place around yourself, because then it puts up like railings so that if you try to go outside tiny difference. Everything is like you've got like lightsabers, sure, like they use a little paddle, one for each. Yeah, like lots of it was like this is like an open source like game. Yeah.
They had like different computer manufacturers had headset. Like HP. And maybe I don't know. They may not out here something. All the different. Yeah, Samsung one, the HP one, and this one.
Yeah, Courtney, you see, I changed the background.
Oh, yeah.
So you can see I'm like in a future city. There are different ones you can choose. Try this one. Yeah, like you are in a space hotel. You can turn around 360 degrees and up. I got a little bit dizzy, when I use the space station app, Yeah, it's tricky.
You don't want to read your head too fast. Yeah, like, well, I wonder what people are doing. Manufacturing like scenarios in a factory.
Yeah, you see.
Yeah, like you're just doing your job and you're just like running into things.
Yeah, you see, this is like a.
That's why there's more emphasis on the AR thing, where you can sort of see the object plus something like. Yeah, I wonder if yeah, also. I'm not sure. I've seen demos of that, like the space tech info where they have the AR thing where you can sort of look it apart and then you can have some glasses or something on your computer that'll show all the parts of it. You can click on a part and get all the stuff here.
Yeah, potentially, if we got some funding, we can get maybe 5 of them, or the people can interact. This is like a museum type place, and that's why I said.
Did you download all these from a website or something?
Yes, actually this is a computer. The headset is a computer, and it's hooked up to the Wi-Fi. So I'm casting to my computer.
Right, but I mean the apps that you're looking at.
Yeah, you can even open the browser.
Oh, okay.
There's also, let me see if you can. There's an app.
Is it possible to share the link to Mars VR?
You want me to post it?
Yes, please.
Yeah, I will. I will post it. Oh, you mean now?
If you have it handy, otherwise we can look for it later.
To show that here? Yeah. If you want me to show it here, I need to get to the.
Or put it in the chat, maybe.
Okay.
I'm not sure. I haven't tried it. Maybe.
It'd be kind of cool, so you don't have to get a monitor.
Actually, you can see here, you can connect to your Facebook friend. So actually you can interact with them if they have the headset.
Friends from high school, you'll find them on the Oculus.
And then you can record video, screen capture. Let me see. Where's the browser? Let's see. Here.
There's a way to test it. We can test on the TV, but
yeah, you see, this is the virtual moon thing that I think there's immersive. Let me see if this is the one. Okay, I click the immersive. Now you see, right? This is,
Oh, okay.
this is what they developed. They just talked about the virtual moon.
Cool, that's cool.
So you can see I'm watching, I think that's the lander. Where is the lander?
I can't see anything, it just looks black on the screen.
Yeah, another,
Yeah, it's like you can see stuff. It's probably because the light is too bright. Yeah. That blocks out all the light, that's what you're looking at in your screen.
well, basically, you see, it's very powerful. It's kind of, you know, like you are on the moon, on the Mars, and we can have council meeting here, you know. Yeah, if AIAA gave us money, everyone got the VR headset. So this is what they talk about. I think there's a, you need to activate it somewhere. There's a landing procedure, but I don't see it right here. Yeah, mainly we are testing your the Apollo sizing. Is this one? This is blinking. No, maybe not. I tested before, it seems to be working, but I don't see it right here. You can see the landing procedure.
Are you looking at the Apollo 11 landing experience or the static scene?
Oh, let me see. It's the, well, it's the moon.espaces.com/go.
Yeah, that's the landing experience.
Oh, okay.
If it, you know, when it ends, it just ends and stays there. So if you want to restart it, you reload the page and it restarts it.
And I see the microphone, I mean speaker side. Is there any sound?
Yes, you have to click on that.
Yeah, I can cast the picture onto the screen, but I don't, the sound probably need to use the Oculus link. So basically it's like a computer. You can browse website. I actually tested Zoom. You can actually, they have Zoom on VR. but the Zoom on VR is just still like 2D. So that's why I'm trying to test what I show you, the VR meeting and the like the spacing. Because it's like you are in a meeting room and you have an avatar, and then you can like a whiteboard, you can join there.
Do you like create an avatar for it or?
Yeah, I don't think you can create very complicated avatar. The second life, actually you can create your avatar that Felipe mentioned. I actually have been testing on that. We have a speaker, he actually talked about the second life.
Oh, yeah.
Yeah, so.
Jeff Michelle was talking about real estate. I think Second Life had a big real estate thing going on, where people were spending real money on
That's right.
Second Life real estate for their homes and stuff, for like their virtual homes. And yeah, and apparently it was a huge thing at some point. I've heard some old people, even a little bit older than I am, like talking about it, like they got into it over 20 years ago or something. And I was like, dang. Yeah, it's interesting because there were some people who were like early adopters.
Oh, here's the landing.
They talked about it.
I try to focus on this so you can see. Did you see it, the landing? Not yet.
I can only see this.
So next to it.
I think, yeah, when they were doing the presentation, I didn't see it until it was like really close to the ground. Yeah.
Well, you'll come down.
I think it's just too bright on the screen for us to see it.
Oh,
Yeah.
well, it's coming down anyway, you will see.
Yeah, if it gets close to the ground, we'll be able to see it.
Yeah.
I hear you say you're from Indiana. Where are you from? Oh, yeah. I'm from Indianapolis. Oh, so I went to Benedict High School. Like rival school. Yeah. Way before you were in high school. So, like everyone makes fun of us. No, I know. We always thought they were the rich kids. I mean, listen, that school is huge. That's the problem. There's like 5,000 teachers. Save a lot of money. No, oh, wow. It's not, no, it's getting ridiculous. Like they should split it up to 2 private schools. But we don't want to do that.
Yeah, I was in the marching band, so Carmel was like a band. But when I was in Davis, it was
Did you see anything?
we had 3 years in high school. They have 4 now. We're the biggest 3-year high school. in the state.
Yeah, did you see
We won
anything?
state like 5 years in a row, and then when my sister's class got there, they didn't win it. And she was so sad because like, my class won all 3 years, and the 2 years before me, they won 2. And then her class, it was like, yeah.
Karen, Courtney, did you see anything?
Oh, there it is. Oh, yeah. Well, it was more like my husband, but I stayed, so I've been out here for more than 20 years now. 25 years this summer. Yeah, just, we moved out in 97. It was after my.
Yeah, Mike,
I'm getting married to this guy.
can you see it?
First husband. I got married early, and he,
Yeah, sorry, I cannot share
tried to do that.
because if I share, then, other people also can have to see it. Hopefully we can get another one.
Stayed there for a while, but it's just whatever, not too long after that. It was really bad for a minute. Had one son already, and then when I got here, and our lifestyle was kind of weird. Like, he was hanging out with graduate students at UCLA, and I was taking care of kids and working.
Oh, it's too bright.
So yes, but I decided to stay here. I had a good job. And I was like, moving back to Indiana. I mean, listen, I was trying to get out of Indiana a little bit. I was like, love this place, great place to grow up. But yeah. You said you went to Purdue. I didn't even do that. I was like, I'm not going to Purdue. I'm too familiar with that. So my tuition was just, and I wanted to do aerospace engineering, so it just didn't make sense to go somewhere else and probably go to a law school or study for aerospace. My dad was like, I applied to go to law school, like I got into it. My dad was just like, who's paying for me? Yeah. I mean,
For what?
you have to, yeah. Like the but I wish it would, and they had a tuition list, so I don't know if it's still for in the state. Oh, I remember they were doing that. Yeah. So I started doing this graduate in 2020 from UC Santa Barbara, or Santa Cruz, I mean. Okay. And the California state tuition.
Yeah, so basically that's the idea.
Housing. And so yeah, between the two, it was like.
So I kind of finished the networking session. Hopefully next time we have more gathering together.
Yeah, no, it's tough. The interest free during the pandemic has been really helpful for both of us. Because he has some loans and I have some that pay for it too. Yeah, I think he's gonna have to start watching and see if that can cancel some of it. I don't know. I don't even have that, but I'm just like, it needs to happen because at this point, the cost is so big. Yeah. Why do people pay?
Oh, maybe the Mars VR is actually what happened is they also put it out on the game platform. So basically need to subscribe to this game platform. You authorize us to do that, and there's a virtual mode, so we can work. So there's no direct link, but I'll check on that, and hopefully you can authorize a public link.
Okay, thank you.
Yeah. Sorry, I misunderstood. I thought you mean the virtual mode. Now I see it. The Mars VR. Yeah, I could probably have set it up to project on the screen, but unfortunately, that computer right now has a distance from HDMI cable. But I can show you the video that he gave a talk to us before, so that could be helpful.